Hello. So in this video, I'll be going through a more challenging probability question from paper 4. So we have 6 numbered cards here, and one card is chosen at random, and we're asked to find the probability that the number is either 5 or 6. So the general formula for probability of any event is the number of successful outcomes divided by the number of total outcomes. So what's the successful outcome in this scenario? It's either choosing a card which has the number 5 or 6, because that's what they're asking us in the question. So how many successful outcomes are there? Well, she could choose any of these 2 cards for it to count as a successful outcome. Therefore, there are 2 successful outcomes. And what's the number of total outcomes? The number of total outcomes is how many which of these cards could she have chosen at the beginning? Well, she could have chosen any of these cards to start with. And there are 6 cards here. Therefore, the number of total outcomes is equal to the number of total cards, which is 6. So 2 over 6 is our probability. And that simplifies to 1 over 3. So now she does this 300 times. And we're asked to find the number of times she expects the number 5 or 6. So for these kinds of questions, we take the probability that we found initially, which is 1/3. That's the probability of taking a 5 or 6 from one card. And since it's the probability of taking a 5 or 6 from one card, we multiply it by 300 to find the number of times she expects it with 300 cards, if 300 cards are chosen. So therefore 1/3 times 300 is 100. So in theory, she expects 100 of the 300 times she chooses a card to be 5 or 6. So now part B of the question. She takes 2 cards at random without replacement. What does without replacement mean? It means, let's say she chose the number 4 on her first card. So she chooses the number 4. And now, when she goes to choose the second card, the number 4 is removed from the deck. It is not replaced. That's simply what it means. It's not replaced, so that means it's not put back into the deck. So when she goes to choose her second card, she's left with just 5 other cards. So now we're asked to find the probability that the sum of the numbers on the 2 cards is 5. So whenever, like if in your exam, if you're given a question about 2 dice or 2 cards and you're asked the sum or the product, you should always be thinking about a sample space diagram. Sample space diagram. So in a sample space diagram, you list the possible options for her first card that she chooses, which are any of the 6 numbered cards. And then you do the same for the second card that she can choose. So these are the options for the first card. And these are the options for the second card. So now we organize this into a grid-like fashion. And to complete the sample space diagram, since we're dealing with the sum of 2 numbers, to fill in the sample space, you look at the column numbers in and the row number and add them up together. So in this case, 1 plus 1, which is 2. So for the next cell, we have 2, that's the column number, and 1 is the row number. So 2 plus 1 is 3. So if you continue this pattern, you should end up with a sample space diagram that looks something like this. So that's what the sample space diagram looks like. But now remember that it's without replacement. So that means that if she chooses a 1 on her first card, it's taken off the deck, and that means that she can't choose it on the second card again. She can't have two of the same numbers. So therefore this cell right here, the 2, is removed from the diagram, sample space diagram. Similarly, if she chooses a 2 on the first card, she can't choose a 2 again on their second card. So it's impossible to obtain a 4 like in this way of choosing 2 of the same cards. If you see, this pattern repeats throughout the whole sample space diagram, and all of these diagonals are removed because you cannot have 2 of the same cards chosen. So now we can start to work on the problem, solving the problem. You can use our general formula, the number of successful outcomes over a number of total outcomes. And in this case, a successful outcome is having 2 numbers with a sum of 5. So all we have to do is count how many cells in the grid have a sum of 5. So that's 1 here, 2, 3, and 4. So 4 of these cells in the sample space diagram have the sum of 5. And now what's the number of total outcomes? The number of total outcomes is the total number of cells in the sample space diagram. So how many cells are there? Well, this is a 6 by 6 diagram. So it has 36 cells. But remember that we removed these 6 from the diagonal right here. We removed these 6 along the diagonal. So we have to subtract these 6 cells that we removed. So we're left with 30 cells in the sample space diagram. So therefore, the successful outcomes is 4. 4 of these cells have a sum of 5. And the total number of outcomes is the total number of cells, which is 30. So therefore, the probability is 4 over 30, which can be simplified to 2 over 15. And that's our answer for that one. Now for the last part of the question, we want to find the probability that at least one of the numbers on the card is a square number. So in probability, whenever they ask you at least, it means that anything greater than or equal to 1. So anything greater than or equal to 1 is at least 1. So therefore, if she chooses 1 square number, that's a successful outcome. But also, if she chooses 2 square numbers from both cards, that's also a successful outcome, since 2 is also at least 1. So now we could find the probability of obtaining 1 square number and then add it to the probability of obtaining 2 square numbers. Or you could remember that the mutually exclusive formula, which I talked about in my other probability video, that is, if she doesn't choose 1 square number or 2 square numbers, she must have chosen 0 square numbers. That's her only other option. And these 2 events right here are mutually exclusive, which means they cannot occur at the same time. So therefore, their probabilities add up to 1. Their probabilities sum to 1. Because it's either this or that. So therefore, we can say that the probability of obtaining at least 1 square number is equal to 1 minus the probability of obtaining 0 square numbers. And this is simpler for us to compute. So, what's the probability of getting 0 square numbers? That means that on the first card she chooses, it's a non-square number, as well as the second card that she chooses. So from these 6 cards, we can see that the only square numbers are 1 and 4. And the other 4 are non-square. So therefore, if she chooses any of these 4 numbers, 2, 3, 5, or 6, that counts as a successful outcome because they're non-square. So therefore, the probability of picking a non-square number on the first card is 4 over 6. So that's equal to 1 minus 4 over 6. But now we also have to consider the second card that she chooses. So let's say that she chooses the card 2. So now remember, this is without replacement. So if she chooses the card 2, it's removed from the deck. And now you're left with 5 cards. You can see, and only 3 of them now are non-square numbers. Therefore, the probability of obtaining a non-square number on her second card as well is 3 over 5. So now we multiply that to 4 over 6 because it's AND. So essentially what this statement reads is, what's the probability of the first card being non-square and the probability of the second card being non-square. And since we have AND, we always multiply with whenever we have a situation of AND in probability. So that's the evaluation of this expression right here. So therefore, the probability of obtaining at least one square number is equal to 1 minus, if you multiply this out, you get 12 over 30. So it's equal to 1 minus 12 over 30. Therefore, the probability of obtaining at least one square is 18 over 30. And that can be simplified to 3 over 5. And that's our answer for that one. That's the probability of at least one of the numbers on the cards being a square number. So yeah, that's all you need to be able to do for probability paper 4. This sample space diagram is really important. So I hope that was helpful. If it was, please like, share, and subscribe, and comment any other problems you'd like me to go through. Thank you very much.